Hi, Year 12s. So I realized that when I was doing the recording for 1.2, well, actually, more so when I was doing the writing of these notes, I forgot the third dot point of this section, which was describe and write equations showing how catalytic converters can reduce the quantities of nitrogen oxides generated by motor vehicles. So I've decided to put this in the second part, so I'll upload it as part 2. Now, catalytic converters, so they are special devices that are placed into the exhausts of motor vehicles, motor vehicles being the major source of nitrogen oxide pollution. What these devices do is they take in the pollutants from the exhaust gas and they what's this catalytic conversion. So it's converting them from pollutants into less harmful products catalytically, which means it happens at a faster rate from a given for a given temperature. So if I were to put these chemicals just straight through the exhaust, they are not going to undergo any further reaction and they're going to come out of the exhaust as pollutants. Whereas if we put this catalytic converter in, it's going to make some reactions that wouldn't have happened happen. Now, the reason why we want these reactions to happen is because these reactions are, again, converting these pollutants into less harmful products. Yeah, they do this using a few components. One thing is inside it, it's like sort of a baffle or a honeycomb structure, and that means that there's lots of surface area. So inside here we have lots of surface area for the exhaust gas to go through, so that the exhaust gas is always touching, the catalyst, the substance that's going to make the reaction happen. Now, it uses precious metals, so this is these catalytic converters are actually quite expensive because they've got metals such as rhodium, platinum, and palladium, which are expensive. It's also why they often get stolen, so people will climb under cars and cut them out, and then sell them for the metals inside. Either way, ignoring that little sidetrack, the metals themselves are embedded in sort of like a ceramic layer inside that prevents them from being blown out through the exhaust. That keeps them there, keeps them working for the life of the vehicle. Just again, as another aside, some vehicles, you can actually get the catalytic converters getting ruined. Some stuff happens in the exhaust gas that makes them not work anymore. But again, not super important right now. We care more about the chemistry for the moment. Now, this is a very rough sketch. So we have the engine just on this side, where the exhaust gas comes out of the engine and then into the converter. And specifically, we're looking at the carbon monoxide, the nitrogen oxide. You also have HCs, so that's unburnt hydrocarbons. Actually, while we're here, I might as well chuck them in here. The fuel itself is hydrocarbons, but if they don't get burnt, like some of it doesn't get burnt, they will go out of through the exhaust and into the atmosphere, and we don't want unburnt fuel being shot out the atmosphere either. Now we have our three major pollutants there, and what comes out of the end is going to be carbon dioxide, which is, while obviously not great, climate change wise, it's not a poison in and of itself. We have N2, nitrogen gas, which is certainly harmless considering it makes up around 80% of the air. And we'll also have, while I'm here, we'll have water vapor. So that water vapor is mainly coming from the hydrogens in the hydrocarbons. So we have all three of those substances are not going to be negatively impacting people in the short term. So again, CO2, climate change, etc., but we're not really concerned about that for the moment. So here we have a reaction. So it is showing a net reaction that occurs that happens between our carbon monoxide and our nitrogen oxide, and it makes our CO2 and our N2. So we have our two reactants. Now we need two of each. We also need to make two carbon dioxides, and we'll end up making one molecule of nitrogen out of that. So you will need to remember this reaction as it's an example of the reaction that occurs in the catalytic converter to take our pollutants and convert them into our relatively harmless products. Now, another important point is this one here. Now, like I said before, these reactions would not be happening inside the exhaust gas unless we have this catalytic converter here to make the reaction happen faster for whatever temperature the reaction's at. Now, even though the catalyst allows these reactions to happen at a lower temperature, they still will benefit when the reaction is at a higher temperature. So they're still going to happen faster when it's hotter, even if it's not having to be stupidly hot for the reaction to happen. So what this means is they actually place the catalytic converter right after the engine. Now what this means is the exhaust gas is as hot as it's going to get. It doesn't have time to cool down as it moves down the exhaust. So that means our catalytic converter is going to be as hot as possible, which will allow it to catalyze the reaction as good as possible. And another point which I haven't actually mentioned here, and that is until the catalytic converter actually warms up a bit, warms up to operating temperature, it doesn't really do a great job of catalyzing the reactions. So again, another aside, because that's what I do. While in my PhD that I was doing, which as you probably know I didn't complete, we were researching materials that could be catalysts at room temperature. So they would catalyze these reactions immediately as soon as the car was turned on, so that you didn't have some of the unburnt fuel, the carbon monoxide and nitrogen oxides being released into the atmosphere as the car is still warming up. Now, I think that completes this section. Again, sorry that I missed this part. Yeah.